Let's start off simple. What is friction? As defined by Google, friction is the resistance that one object or surface encounters when moving over another. In other words, there's slippage. Friction tends to be great between rough surfaces and less between smooth surfaces. So for example, the friction between the tire of a car and the pavement would be a lot greater than that between a skate on ice. Now, what about friction on a surface as flawless as glass? If our theory is true, we would expect it to have close to no friction. But is this the truth? It is true that glass is smooth, and most of its friction comes from its electrostatic properties. Therefore, its friction is determined by the object moving against it. But what if we tried to find the friction between two pieces of glass? Could we achieve infinite friction? Let's find out.
The materials we will use for this experiment are two very smooth pieces of glass and a Newton spring scale. First, we attach the two pieces of glass together, and then we attach the Newton spring scale to the top. We will pull on the Newton spring scale to determine the amount of force we need to overcome static friction. With a force of 20 newtons, we will try and pull the two pieces of glass apart. As you can see, the two pieces of glass have not budged. We are adding a second spring scale to pull it with a bigger force. As you can see, we use lots of tape. With a combined force of 40 newtons, we will try and pull these two pieces of glass apart. Once again, as you can see, these two pieces of glass will not slip. As we mentioned before, the bonding between the two pieces of glass happens because of glass's electrostatic properties. The neutral ions in the glass transfer electrons, forming positive and negative ions. The electrostatic properties and attractions between the positive and negative ions holds the two pieces of glass together. Coming to effect is Coulomb's law: opposites attract and likes repel. The ionic bonding was only possible because the two pieces of glass were smooth and clean, allowing no extra dust particles to come between the glass's atoms. Ionic bonds are extremely difficult to break and almost impossible to do so by hand, creating your quote-unquote infinite friction.